Question number 38. This is also a case study question. This is a trigonometry and a little bit of speed, distance, time also thrown into it. Right. Again, useful information. Read it. Pause the video. Read it. Once you're done reading, play the video. We'll quickly jump into the next one, assuming you have read this part. Right. So essentially, given some more information here. Right. This is where things start getting interesting. This is where the question actually starts for our purposes. At a given instance, ATC finds that, air traffic control finds that the angle of elevation of an airplane from a point on the ground is 60 degrees. Okay, we'll draw this, right? That's the first question. Draw a neatly labeled diagram to show this above situation, right? After a flight of 30 seconds, it's observed that the angle of elevation changes to 30. So angle of elevation moves from 60 to 30 in 30 seconds. The height of the plane remains constantly at 3000 root 3 meters. Height does not change. It's basically that it's moved further away from where you're looking. Therefore, the angle of elevation has dipped. Use the above information to do this. Draw a neat labeled figure to show the above situation diagrammatically. Let's start with it. Let's go to the other questions later. Right. So this is where the air traffic control is viewing it. So the first point is here. Right. So this we'll say is equal to angle of elevation is 60 degrees. This height at which the flight is traveling is 3000 root 3 meters. We'll fill this number, which is 3000 root 3 meters. This is the initial point. We'll call it as point 1. Now, after 30 seconds, at the same height, we are not changing the height at all. We find that the flight has moved further away, and therefore at this point, if you look at it, the angle of elevation has actually come down to 30 degrees. The height still remains the same at 3000 root 3. This is 0.2. This is what we have, right? So this is the neatly labeled one. So we can say this is the ATC, this is 0.1, 0.2. We can give it as ground 1, ground 2. From the ground, this is what we have. So named, labeled everything. 30 degrees is the angle of elevation when it is from ATC to 0.2. 60 degrees is the angle of elevation from ATC to 0.1. So part 1 of this question is done. What is part 2? What is the distance traveled by the plane in 30 seconds? Okay, so we're going to use the same diagram, right? We have two values here, right? 30 degrees, 60 degrees is what we have. The height happens to be 3000 root 3, 3000 root 3. I'll call it as A, B, C, D, E. In 30 seconds, the flight has actually traveled this distance, right? This is what BD is what we'll have to find out. BD is the distance traveled in 30 seconds. Because BD and CE are parallel, essentially BD is equal to CE. How are we going to go about it? We'll start with the triangle ABC. In triangle ABC, let's compute the value of AC. AC equals how much? That's the first thing we're going to find out. AC is the side adjacent to this particular angle 60. The value for which we have BC is the opposite side. So we're going to go with tan of angle 60. Triangle ABC, angle is 60, tan 60, which is equal to root 3, is opposite side 3000 root 3 divided by the adjacent side AC. Cross multiply these two, we get the value of AC to be equal to 3000 root 3 divided by root 3. So AC is equal to 3000 meters. We found out this distance right now. We'll go to triangle ADE. Triangle ADE. In triangle ADE, my objective is to find out the value of AE, which is the adjacent side to this angle, 30 degrees. So tan of 30 degrees is equal to the opposite side DE divided by the adjacent side AE. Tan 30 is 1 by root 3. DE is equal to 3000 root 3 divided by AE. Cross multiply, you get the value of AE to be equal to 3000 root 3 times root 3, which is equal to 9000. AE is equal to 9000 meters. AC is equal to 3000 meters. The distance traveled in 30 seconds is BD, which is equal to CE. CE is equal to AE minus AC, which is 9000 minus 3000, which is equal to 6000 meters. Keeping the height constant during the above flight, it was observed that 15 root 3 minus 1 seconds, the angle of elevation changed to 45 degrees. How much is the distance traveled in that duration? Okay, so essentially we'll go with the diagram, a slightly modified version of this diagram. So this is point A from where we are looking at it. Initially it was at an angle of elevation of 60 degrees. This is A, B, C. A little while down the line, not 30 seconds, 15 into root 3 minus 1 seconds down the line, at the same height, right, DE, we find the angle of elevation to have dipped to 45 degrees right now. So the distance traveled is BD, which is equal to CE right now. How much is the distance traveled in the duration? We have already found out this value. Both of these are 3000 root 3. I'll quickly therefore find out the value of AC. We want to find out BD. BD equals how much? Which is the same as finding out the value of CE. CE is equal to AE minus AC. Objective 1, find out the value of AC. In triangle ABC, we have done it in the last question itself, but we'll redo it right now. We're trying to find out the value of ABC. We're trying to find out the value of AC. Tan of 60 degrees. Tan of 60 degrees is equal to BC by AC. Tan 60 is equal to root 3. BC we know is the height at which the flight is traveling, 3000 root 3 divided by AC. Cross multiply, you get the value of AC to be equal to 3000 meters. Has not changed at all. It can't, right? The values are all the same. We're going to take this diagram to the next slide and we'll find out the value of AE in the next one. So this is point A. This is the initial point. This is the subsequent point. Both are at a height of the same 3000 root 3 A, B, C, D, E, right? We are trying to find out now this being 45 degrees. AE, let's compute. Known that AC is equal to 3000 meters. Tan of 45 degrees, we are looking at right triangle ADE. Tan 45 degrees is equal to DE divided by AE. DE being 3000 root 3 meters. So tan 45 is the one, D is 3000 root 3 meters divided by AE, which means AE is equal to 3000 root 3 meters. Pretty much the same as what we did in the last part, right? We had 6000 there, now it is 3000 root 3. So in these 15 root 3 minus 1 seconds, what is the distance travel? CE is equal to AE minus AC, which is 3000 root 3 minus 3000 meters, which is 3000 into root 3 minus 1 meters. What's the speed of the plane in kilometers per hour? Right, we essentially know that at point 1, when the angle of elevation was 60 degrees, right, the distance from the air traffic control was basically 3000 meters. When the angle of elevation was 30 degrees, we know that the distance from the air travel control, ATC, was 9000 meters. Therefore, the distance covered, right, and to travel this distance, it took essentially 30 seconds. So speed is equal to the distance covered, which is 6000 meters, divided by the time taken for it, which makes it as 200 meters per second. Usually speed is given in kilometers per hour. Let's convert that. So 200 meters divided by 1000 would have given the answer in terms of kilometers. Now we want the seconds, it is number of seconds is essentially converted into hours, which is equal to 1 by 3600. So the denominator will have a 3600, goes to a numerator and makes it as 3600 by 1000. So cancel this extra zeros, these two go, this also goes. 36 into 20 makes it as 720 kilometers per hour. Essentially divided the numerator by 1000 and the denominator by 3600. So 1000 by 3600, you can actually do it this way also. You can say that, hey, I am essentially doing a 5 by 18 division, or multiplying it by a 18 by 5. Multiply this 20 by an 18 by 5, get the answer, which is equal to 720 kilometers per hour. Before you leave, I want you to do two things. One, sign up at online.maxtute.com to get started with CBSE Class 10 Math online tuitions. It takes all of 5 minutes and less than 3 steps to get started. So get it done today. And second thing, I want you to subscribe to this channel if you already haven't, and turn on notifications so that you get notified every time a new video is uploaded. And also, spread the word about this channel to your friends and classmates.